In this last video, or in this last lesson of Chapter 8, we're going to talk about the applications of similarity and what we can do with them. So, we spend all this time learning all this algebra and all this math and how to do all this stuff, but very rarely do we get a chance to actually see where it would apply in real-world situations. So this is one of my favorite chapters because we can actually do that now. Although, with that being said, if you ever find a guy that's 3 feet tall that looks like a chimney sweeper, you might want to run, because in a real-world situation, that thing is a leprechaun and it's coming after you. You know what I mean? So, let's just set this up, though. If you had a 3-foot leprechaun right here, and he cast a shadow of 4 feet, and you had a similar situation happening with a tree that casted a 40-foot shadow, how tall is the tree? Excuse me, and no, I do not have corona, don't ask. But if we set this up as a proportion, we can cross multiply and solve. So 3 times 40 is 120, and then 120 divided by 4, we'll get that x is equal to 30. So our tree is 30 feet tall. Okay, moving on along here. How far must a biker travel from point A to point E? So we're trying to find this distance right here. If DP is 3 meters, AC, so this entire thing, is 50 meters, and BC is 4 meters. Okay, you kind of have to look at this as if there's 2 different triangles. Okay, you have the big triangle that's x and 50, and then you have a smaller triangle on the inside here that's 3 and 4. So that's exactly how I'm going to set it up. I'm going to say x is to 50 is equal to 3 over 4, and then I'm going to cross multiply and see what I get here. So 150 divided by 4 gives us approximately 37.5, and that's in meters, 37.5 meters. Okay. I'm trying to find something that we haven't seen yet. We haven't really seen one about the lake, so I'll go ahead and do this one too. It says, how wide is the lake AB? So we're going to pretend like this is a lake. It wants to know how wide it is. If DE is 9, DC is 15, and DB, which is this entire thing, is 81. Now, it's great that it's given us the entire distance, but we don't need the entire distance. You have 2 triangles here. You have a blue triangle that's on top, and you have a green triangle here on the bottom. Both of these triangles are similar, okay? But the thing about it is I need this side right here. I need from B to E. I don't need from B to D. So to find from B to E, we're actually going to say 81. Doing that thing again. Okay, 81 minus 9. Okay, 81 minus 9. And that'll give us that this side is actually 72. Okay, 72. So we're going to set up a proportion now, and I'm going to do it a little differently this time. I'm actually going to do x over 15 is equal to 72 over 9. And then I'm going to cross multiply. So 9x is equal to 1080. And then if you divide both sides by 9, you get that x is equal to 120. So our lake is 120 feet wide. Okay, so let me keep going here. You can do the problem about Hillary. She's a little bit taller. She's 5 feet tall, so you can do that problem if you'd like. Down here, it says to find the value of the variable in each if they are, you may have to use Pythagorean theorem. We haven't even done Pythagorean theorem yet. If you remember how to do it from 8th grade, 9th grade math, then go for it. But if not, then just set up proportions and solve like we've been doing. It will be just fine. Every single one of these will work itself out. Now, there's one in particular, though, that I do want to see, and it's this number 6. You have 2 triangles. You have the big blue triangle, and on the inside of that, you have the smaller green triangle. So when you're doing this, you have to compare the blue to the green, okay? Well, the green triangle has a side of 6 and a side of 3. The blue triangle has a side of 8, and this base down here is not B, so don't call it B. The base is actually B plus 3, because you want the whole thing. So when you're setting this up, please make sure that you're careful to do that. Distribute your 6, and then you can solve from here. So 24 minus 18, 6 is equal to 6b, so it looks like b is actually just going to be 1. Okay, and that's fine. You can have a b that's 1. There's no rule saying that we can't. All right, trying to look for something that looks like it might be kind of difficult, and excuse me, I'm not really seeing anything too crazy. I think most of this is stuff that you probably can already do. What I would do if I were you is I would work this out on the blank notes that I gave you, and then you can look back at the notes that have the answers there to see if you've been doing it correctly. I would try it by yourself first. This is just extra practice. Okay. Use indirect measurement to solve each problem, rounding answers to the nearest whole number. All right. This is just a fancy way of saying, you know what, this is a real world problem and there's no picture, so you're going to have to draw your own picture, okay? And don't pretend like you don't know what this stuff is. Y'all know what a flagpole is, okay? It doesn't have to be a very artistic picture. It could actually just be like a triangle. You know, that's what we're dealing with here is triangles. It says if a 4-meter flagpole casts a 6-meter shadow. So here's our meter, here's our shadow. So it's 4 meters and a 6-meter shadow. At the same time, nearby, a building cast a meter, or it says a building cast. So I don't know how tall the building is, but I know the shadow is 24. How tall is the building? Okay. Now, I want you to imagine, you know, I know I said that these are going to be triangles. Well, they are. They're actually right triangles. Because, of course, a shadow, if it's being measured compared to something that's standing straight up, it's going to be perpendicular to the ground, forming that 90-degree angle. And you could, if you needed to, draw, a hypotenuse going that direction if it helps, okay? But either way, you're going to set up a proportion here. It's going to be, I'm going to do 4 over x this time is equal to 6 over 24. But remember, there's so many different ways to solve this. You could have said 4 over 6 is equal to x over 24. You could have said 24 over 6 is equal to x over 4. So many different options to solve these problems. Okay, so you're going to get 6x is equal to 96, of course. And then if you divide by 6, 96 divided by 6 is 16. So we find out that the building nearby is approximately 16 meters. Okay, we have another shadow question and we have another flagpole question. So both of those are fairly simple. So now let's take a look at these at the bottom here. And that's, of course, supposed to say is triangle. Of course, it's not using the right notation. But it wants to know if these triangles are similar. Now, again, let's just review what we have learned. I am so sorry if y'all hear my husband screaming in the background. He's playing Tickle Monster with my child. But let's just review what a similar triangle has to have, okay? It either has to have all 3 angles that are congruent, so it has to have that angle similarity theorem. It has to have all 3 sides that are proportional, or it could have a side, another side, and the angle in between, okay? That doesn't mean they have to be congruent. It means they have to be proportional, all right? So looking at this first one, I noticed that it has an angle and it has 2 sides. So if it is similar, we're probably going to be looking at the side angle side similarity theorem there. The angles are congruent, so now we need to see if the corresponding sides are proportional. So let's see if 37 is proportional to 30. We'll see if that has the same ratio as 30 over 28. Now, we did this in section 8-1. I told you probably the easiest way to do it was to turn them into a decimal. So if I turn this into a decimal, it's 1.23 repeating. The other side, minus 28. Uh-oh. Sorry, Lake, that was your mama. Uh-oh, let's not do that. But the other side would be 1.25. Okay, so if you have these set up and you notice that the decimals are not the same, then that means that these are not similar. Okay, they have to actually have the same ratio for them to be similar. Okay, the second one. I see that it has two congruent angles right here. So now let's check the sides. So I'm going to check and see if 96 corresponds, or what its ratio is with 84, and then 104 with 91. So let's just turn these into a decimal, see if we get the same thing. This one's about 1.4. Uh-oh. Wouldn't be congruent, it would be equal if it happens. Let's see. 104 divided by 91 is approximately 1.14. So these are equal, and so because of that, this does have side angle side similarity. It does have side angle side similarity, okay, or it's similar because of side angle side similarity theorem. All right, guys, work on the homework. Again, if you have any questions, this is all that we're going to learn for Chapter 8. I'm not going in depth with anything else. This is it. So if you have any questions, if there's something that you're not understanding, please, please, please let me know. Okay, have a good day.